Right, so in this video, we're going to be exploring concepts related to trigonometry. So we first start by considering acute angles. So the trigonometric ratios of acute angles. So let's say I were to give you a triangle, and if I call this angle theta, so it's a right angled triangle, then the side opposite the angle, which is this side, will be the opposite side. The side opposite the right angle will be the hypotenuse, and the remaining, the last side will be the adjacent side. So we're just going to define a few ratios. So sine theta is opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals to opposite over adjacent. Right, so to find sine theta, you just take the length of the opposite side, divide by the length of the hypotenuse, for example. So take note that these are ratios. Okay, so you're taking, for example, length divided by length. So there are no units associated with these ratios. So we will need to consider some special angles. So if, let's say, theta is 30 degrees, 45 degrees, or 60 degrees, then we would need to be familiar with the sine, cosine, and tangent of these angles. So to do so, we can actually just use a few right-angled triangles to help us. So since these are right-angled triangles, so we can actually make use of Pythagoras' theorem, which states that a squared plus b squared equals to c squared. So if we want to find the length of this side, so 1 square plus m square equals 2 square. Right, so we see that m square is 4 minus 1, which is 3, so m is square root 3. M is square root 3, we just consider the positive value. Go ahead and replace this m with square root 3. Similarly for this, if we want to find this length, is the square root of 1 square plus 1 square. So it's square root of 2. So this side is square root 2. So we can go ahead and try to figure out what are the different special angles. So let's start with sine 30 degrees. So if we consider this triangle, so sine 30 degrees, sine is opposite over hypotenuse, so opposite is 1, hypotenuse is 2. So we know that sine 30 degrees is 1 over 2. You can fill this in. Next, we can find cosine 30 degrees. So cosine is adjacent over hypotenuse. So we have our 30 degrees here. We want to find the adjacent side. So adjacent side is this side over the hypotenuse. So it's this side. So it's square root 3 over 2. So next we want to find tangent 30 degrees. So tangent is opposite over adjacent, so opposite over adjacent, so it's 1 over square root 3. Next we consider sine 45 degrees. For that we consider this right angle triangle, so we can take any angle because it's both 45. So sine is opposite over hypotenuse, so opposite is 1, hypotenuse is square root 2. So sine 45 is 1 over square root 2. Likewise, cosine 45 degrees. For cosine 45 is adjacent over hypotenuse, so it's adjacent over hypotenuse, so also 1 over square root 2. Tangent 45 degrees. So tangent is opposite over adjacent, so opposite over adjacent, so it's 1 over 1, so it's just 1. If we consider 60 degrees, we can work it out as well. Alright, so next we consider sine 60 degrees. So consider this triangle, so 60 degrees, sine is opposite over hypotenuse, so it's this side over this side, so it's square root 3 over 2. It's sine 60, so cosine 60 degrees. So cosine is adjacent over hypotenuse, so it's adjacent over hypotenuse. It's 1 over 2. It's half. So finally we want to find tangent 60 degrees. So tangent is opposite over adjacent, so opposites over adjacent, so it's square root 3 over 1. So it's just square root 3. So we have already completed our table here, so we can clean it up a little by recognizing that if we rationalize the denominator, we can get square root 2 over 2, square root 2 over 2. So how you do this is you times square root 2 on the top and the bottom. So square root 2 times square root 2 will give you 2, and 1 times square root 2 will give you square root 2. So you will get this. So likewise for this one is equal to square root 3 over 3. Next we are going to discuss about complementary angles. So angles are complementary if they add up to 90 degrees. So for example, 30 and 60, they are complementary, and 45, because they add up to 90. So if we consider sine 30 degrees, which is half, can you see that it is also equal to cosine 60 degrees? If we consider sine 45 degrees, which is square root 2 over 2, can you see that it's the same as cosine 45 degrees? So this is not a coincidence, it's because there is an identity which states that sine, say theta, is equals to cosine 90 degrees minus theta. So this is true. So you can put in any angle for theta here. Sine of that will be equal to cosine of 90 minus the angle. So we can actually prove this by considering yet another right-angled triangle. So if this is theta, then this angle will be 90 degrees minus theta. Right, because the sum of all angles in the triangle must equal to 180 degrees. So if this right angle is 90 degrees, then the sum of the other two angles must equal to 90 degrees, right, to make up 180 degrees in total. So if we were to consider sine of theta, alright, let's say we just label this A, B, and C. Consider sine of theta, which will be opposite over hypotenuse. We will get A over B. Sine theta equals A over B. If we consider cosine 90 degrees minus theta, so cosine is adjacent over hypotenuse. So adjacent, which is A, over hypotenuse, which is B. So you can see that they are equal. So there's also a version of this for tangent. So if we consider tangent 30 degrees, it will be 1 over tangent 60 degrees. As you can see, tangent 30 is 1 over square root 3, tangent 60 is square root 3. So in general, tangent theta will be equal to 1 over tangent 90 degrees minus theta. So if you consider this, tangent theta is opposite over adjacent, so it's A over C, right? A over C. But tangent 90 minus theta, right, which is opposite over adjacent. So opposite over adjacent, so it's C over A. Right, so that's the proof for this. So tangent theta is opposite over adjacent, so it's A over C. Tangent 90 degrees minus theta is C over A. Right, so that's the proof for tangent theta equals to 1 over tangent 90 minus theta. So now we're gonna be discussing degrees and radians. So usually for trig we will use radians, but you are probably more well versed with degrees, so we have to shift our mindset a bit. So first I will introduce to you what is a radian. So very formally speaking, the radian is the angle subtended at the center of a circle by an arc equal in length to its radius. So what it's trying to say is, let's say I have a circle of radius r, and I were to consider an angle such that the arc length here is equal to the radius of the circle, then this angle will be 1 radian. Yeah, so this is what it means by angle subtended at the center of a circle by an arc equal in length to its radius. So basically, if you go halfway around the circle, 180 degrees, it is pi radians. 180 degrees is pi radians. So if you go one full circle, 360 degrees, it will be 2 pi radians. Right? So how do you convert from degrees to radians? So if you want to convert from degrees to radians, let's say you have some degree, you want to change it to radian, you times pi over 180 degrees, and that will give you your answer in radians. So if you want to convert from radians to degrees, then some angle in radians times 180 degrees divided by pi radians. That will give you your answer in degrees. Yeah, so it might take a bit of time for you to get used to, but actually it's just a matter of proportion. Right, so previously we have discussed trigonometric ratios for acute angles, but now what we want to do is we want to extend it to any angle. We can do this by representing angles on a Cartesian plane, such as this is an xy plane, a set of axes. So what we're going to do is we're going to define an angle theta. So let's say there's this line here, we want to find this angle theta. So this is considered an angle, a positive angle in the first quadrant. So this is the first quadrant. Always start from the positive x-axis over here, and you go in a counterclockwise position for positive, to move in the positive direction. So this angle theta is a positive angle, and it is in the first quadrant, so as long as it lies between 0 and 90 degrees. So next, if you consider a line here, and if you consider this angle theta, it is still a positive angle because you are moving counterclockwise from the positive x-axis. So this is a positive angle, but now the angle is in the second quadrant. So likewise, this is the third quadrant. This is the fourth quadrant. So for each of these angles, there is an acute angle for each of these. So this acute angle is sometimes called the basic angle or the reference angle. So it's an angle that is always positive, okay, and always acute, and it lies between the x-axis and the line segment. So what am I talking about? So for the first quadrant, the acute angle is here. Call it alpha. For the second quadrant, the acute angle will be here. Third quadrant, it will be here. Fourth quadrant, it will be here. Right, so the acute angle is always between 0 and 90 degrees. So it is only for the first quadrant that the angle theta is equal to the basic angle. So let's say I were to have an angle theta. As you can see, we are moving clockwise now instead of counterclockwise. So this is a negative angle. A negative angle in the fourth quadrant. So this is also another negative angle in the third quadrant. Second quadrant. First quadrant. Since all these angles move in a clockwise sense from the positive x-axis, so they are negative angles. So similarly, there are basic angles for each of these. Alpha, so you may be wondering, why do I need to define this this basic angle, this acute angle. So if we were to consider this line segment and we were to draw a line down that's perpendicular, you will see that you get a right angled triangle. So this is theta. So can you see that the x value is actually r cosine theta, and the y value is actually r sine theta. Okay, so I write it down. X is r cosine theta and y is r sine theta. So we can see that cosine theta is x over r and sine theta is y over r. We can also define tangent theta, because tangent theta is opposite over adjacent, so it's actually r sine theta over r cosine theta, which is y over x. So by doing this, we can extend our understanding of trigonometry to any angle by making use of the Cartesian plane. How do we do that? So I'll illustrate it through an example. So let's say you're given a question: the line OP with the coordinates P, -3, 4 makes an angle of theta with the positive x-axis. Find sine theta, cosine theta, and tangent theta. So I'm just gonna draw a line. This is P, -3, 4. So basically this is -3 and this is 4. So is given that it makes an angle theta with the positive x-axis. So by using our definition that we derived above, can we find sine theta, cosine theta, and tangent theta? So yes, we can. So sine theta is y over r, which is equals to 4 over r. So r is the length, so we can find it by Pythagoras theorem. So -3 square plus 4 square, and we square root. Yeah, so it's 4 over 5. Next we can find cosine theta, which is x over r. So x is -3, r is -3 square plus 4 square, square root. So this will give us -3 over 5. Tangent theta equals to y over x, which will be equals to 4 over -3, -4 over 3. Right, so it's given in the question, x and y. So from here you can see that basically when this theta is not acute, some of the trigonometric ratios will not be positive. So in this case, in this quadrant, for cosine and for tangent it's negative, but for sine it's positive. So let's consider the signs of our trigonometric functions in all 4 quadrants. So consider theta. Let's say this angle is in the first quadrant. So we can see that the x value is positive and the y value is positive. So sine theta here, which will be y over r, okay, so r is always positive, so since y is positive, so positive, cosine theta is x over r. So x is positive, so cosine theta is positive. Likewise, tangent theta, which is y over x. You're taking a positive number divided by another positive number, so it's positive. So you can see in the first quadrant, all three trigonometric ratios are positive. So next, let's consider the second quadrant. Getting a little cluttered. So in our second quadrant, we can see that x is less than 0, but y is more than 0. So likewise, sine theta is y over r. Since y is positive, so this is positive. Cosine theta is x over r. So you're taking a negative number divided by a positive number, so this is negative. So tangent theta is y over x. So you're taking a positive number divided by a negative number, so it's negative. So in the second quadrant, only the sine of the theta is positive. Cosine and tangent is negative. So if we consider the third quadrant, for the third quadrant, x is less than 0 and y is less than 0. So both negative. So sine theta, which is y over r, we're taking a negative number divided by a positive number, so it's negative. Cosine theta is x over r, so we're taking a negative number divided by a positive number, so it's negative. So tangent theta is y over x, negative divided by negative, so it's positive. So in the third quadrant, only the tangent is positive. So if you consider the last quadrant, x is greater than 0, but y is less than 0. So sine theta is y over r. So you're taking negative divided by positive, so negative. Cosine theta, x over r, positive divided by positive, so it's positive. Tangent theta, y over x, negative divided by positive, so you get negative. Right, so in the last quadrant, the fourth quadrant, only the cosine is positive. So you can spot a pattern. So for the first quadrant, everyone is positive, so all are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. In the fourth quadrant, only cosine is positive. So this will be very helpful when we solve problems. So let's say I have an angle theta, which is in the third quadrant. So then the basic angle, and the basic angle alpha will be here. So if I were to consider sine theta, so sine theta is y over r. So if I were to call this A and this B, so where A and B are positive, so y over r will be negative b over r. Right, then if you were to consider sine alpha, it is b over r. B over r, so it's negative sine theta. Okay, but if we were to say consider this angle theta, in the fourth quadrant we have to consider the cosine of theta. It will be x over r. So if I were to consider this as a and r, so x over r will be a over r. And if I were to consider the basic angle alpha, then cosine alpha would be a over r, which would equal to cosine theta. So over here we see the difference. So there is a negative sign here because in the third quadrant sine is negative. So when we consider the relationship between sine of theta and sine of alpha, we need to add a negative sign. But in this case, since we are considering the fourth quadrant, okay, so cosine theta is positive, right? So we do not have to add a negative sign. Yeah. So let's say I have some angle theta, and I were to consider negative theta for A, S, T, C. So the value of alpha will be the same. So if I consider sine theta, it will equal to sine alpha, both are acute. If I consider sine negative theta, it will actually be negative of sine alpha, because in the fourth quadrant sine is negative. Okay, so from this, can you see that this is negative sine theta? So therefore sine negative theta is negative sine theta. So if we consider cosine, so similarly, again the alpha is the same angle. So cos theta will be equals to cos alpha, since both are acute. Cos negative theta is the same as cosine alpha, which is the same as cosine theta. So interestingly, we have cosine negative theta equals to cosine theta. So if we consider tangent theta, it will be the same as tangent alpha. Both are acute. So if we consider tangent negative theta, we can see that in the fourth quadrant, tangent is negative, so we have to take the negative of tangent alpha, and negative tangent alpha is negative tangent theta. So this is how we arrive at this conclusion. So this is quite special because you can see for cosine, the negative here actually doesn't affect the value. Right, cosine negative theta is the same as cosine theta. Whereas for the others, the negative sign sort of has to be brought out for sine and tangent. So next, let us try to solve this trigonometric equation. So they ask us to solve for sine theta equals negative half. So take note of the sign negative. So which quadrant can theta appear? Well, theta cannot appear in the first or the second quadrant because sine theta for the first or the second quadrant is positive, so it has to appear in the third or the fourth quadrant. So what we can do is we can first consider the basic angle. So we let sine alpha be 0.5. So take note, this is not negative 0.5. We'll always take the positive value of whatever you're trying to find. So this will be 30 degrees. So this is a special angle. So we know that this is 30 degrees. This is 30 degrees. Right? So if we want to find the values of theta which fulfill this, theta will be 180 degrees plus 30 degrees should be equal to 210 degrees, or theta equals to 360 degrees minus 30 degrees, which will give you 330 degrees. So I considered the domain carefully because we're only considering from here to here, right? 0 to 360 degrees.